Welcome to Simplifying Radicals. And what's going to happen is that we are going to learn and use the fundamental theorem of arithmetic in order to figure out how to do prime factorization. And then we'll use prime factorization in order to simplify radicals. Okay, so what are the factors? Factors are numbers multiplied together to get another number. Well, let's look at an example. So let's look at the number 12. What are the factors of 12? What numbers multiplied together make 12? Well, we know that a number that goes into every number is going to be 1. 1 times whatever number it is will always work. So 1 times 12. Okay. Let's check 2. Will 2 go into 12? 2 will go into 12. 2 goes into 12 6 times. So 2 times 6 is 12. And what is the next number we're going to try? How about we look at, let's look at 3. Will 3 go into 12? 3 will. 3 times 4 does equal 12. And when these two numbers are right next to each other, you know you're done, because then you just flip it around and you go 4 times 3, 6 times 2, and so on. So, and you guys might remember the little rainbow that you did back in probably 4th grade. These two go together, and then these two go together. All right. So the factors of 12, the numbers multiplied together to get 12 are 1, 2, 3, 4, 6, 12. So those are factors. Okay, so as you can see, a prime number, its only factors are 1 and itself. So we know that the factors of 12, there was more than just 1 and 12. 2 and 6, 3 and 4. So it's not prime, it would be compound. However, 2, the only numbers multiplied together to get 2 are 1 and 2. The only numbers multiplied together to get 3 are 1 and 3. 4, 1 and 4 works, but 2 times 2 works as well. 5, it's prime. 6, not only is it 1 and 6, but you've got 2 times 3. So that's the difference between prime and compound. And it is important to note that the number 1 is neither prime nor composite. And another thing that you might want to make note of is that the number 2, which is the first prime number, is the only even prime number. All other prime numbers are odd other than 2, because by definition, an even number is divisible by 2. So 2 is a factor of every other number that is even, which would make it compound. So okay, so as I said, every whole number greater than 1 is either prime or has a unique set of prime factors. So let's start with the very first one, and I think I'm going to write in black, and that is going to be 2. 2 is the first whole number greater than 1. It is prime. The only factors of 2 are 1 and 2, so by definition it is prime. Let's look at the next whole number up. That would be 3. 3 and 1 are the only factors, so it too is by definition prime. Remember what I told you, that all of the even numbers greater than 2 are divisible by 2, which means that the only even number that is prime is 2. So the first even number that we have that is composite is going to be 4. And so let's look at what are the unique set of prime factors. Well, 2 times 2, and as you know, 2 is prime, so there's the unique set of prime factors. No other numbers, no other primes multiplied together make 4, and 2 times 2 does not equal anything other than 4. So let's move up to the next one. Number 5. 5 is prime. Its only factors are 5 and 1. We're going to move up to the next one. Again, it's even, so we know at least 2 is a factor. And the primes that multiply together to make 6 are 2 times 3. Again, unique set of prime factors. 7 is prime. Okay, now, here's the first one that's a little bit different. the number 8. I know you want to say 2 times 4, but the problem with that is 4 is not prime. But 4 is, its unique set of prime factors are 2 times 2. So we know 2 times 2 does not equal 8, but 2 times 2 is 4, and 4 times 2 does equal 8. So there is your unique set of prime factors for the number 8. 2 times 2 times 2. Next number up is 9. It's odd, but it is the first odd number that is not prime. It is composite because, as you know, 3 times 3 does equal 9, and those are both prime. So there's its unique set of prime factors. Next, we have the number 10. 10 is divisible by 2, so we know 2 is one of the primes in it. Any even number is going to have 2 as one of its factors. And 2 times, not 3, but 5. 5 is prime. 2 times 5, there's its unique set of prime factors.